Hello students, welcome to Sri Jayendra's Ring Zone classes. I am your friend and mentor for coming classes with respect to physics. This is lecture number 17 of a unit motion in a straight line. In this class we are going to discuss about the relative velocity. So let's begin with today's class. But before we move on, we are going to discuss about the relative velocity part 1. Basically, uh, two kind of relative velocity questions could be asked. One is the relative velocity when it has been used in motion in a straight line. It's a relative velocity in one dimensional only. And one more unit would be there, which is the fourth unit of class 11. It's a motion in a plane. In there, even a relative velocity would be there. It is a relative velocity with respect to motion in a plane. So in this class, we are just going to discuss about the relative velocity in one dimension. So let's begin with today's class. Let's move on. Yes, look at this. Can you see the car? Can you see the bus? Yes. Let's say this is the velocity of a car in this direction, and even bus is moving in this direction, velocity of bus. Yes. So if you have been asked that find out the velocity of car with respect to bus, let's say this is moving with the 40 meter per second, and let's say this is moving with the 20 meter per second. So in this situation, I will say that a car is moving faster as compared to the bus. My first observation. A second observation should be a car is moving with 20 meter per second higher speed as compared to the bus. I hope these things are clear to you. That I know two situations from this diagram that car is moving faster as compared to the bus, because I know that car is moving with a speed of 40 meter per second and bus is moving with the speed of 20 meter per second. So first thing, car is faster as compared to bus in this diagram, and second is car is faster by a 20 meter per second. Its speed is higher by 20 meter per second as compared to the bus. Now the question arises, how this 20 meter per second came? How could I say that it is faster by 20 meter per second? What what I did is, or what you have simply did it in your brain is, it's a velocity of car with respect to bus, that you have simply performed the subtraction. It's a vc minus vb. Or or look at this very carefully. This is interesting one, that split this 40 into two parts. It's a 20 and 20. I have divided into 20 into 20 because this is having a speed of 20. Now this 20 is carried by both. Even this is has a 20, this is has a 20, but this is have a 20 only and this is have a 20 more. So I can say that this car is moving with 20 meter per second higher as compared to the bus. I hope these things are clear to you. Now let's take one more situation and observe this carefully what they are doing. That I can say that this car is moving in this direction, this bus is moving in this direction. So if I have been asked that what would be the, or find out velocity of car with respect to bus, what should be my answer? What should be my answer? What I want velocity of car with respect to bus. It's a VCB, velocity of car with respect to bus. Let's say VC is in positive x direction, so this is positive x direction, minus of VB, but as it is moving in negative of direction, I should write like this. It's a VC minus of minus VB, so ultimately this is minus minus plus. It's a VC plus VB. Yes, so velocity of both the objects are going to added when they are moving in opposite direction. You can simply feel this, because if two objects are moving, let's say this is first object, this is second object, and let's say this is moving with 10 meter per second, this is moving with 15 meter per second. This is A, this is B. So if A observes the motion of B, if A observes the motion of B, then A can say that B is moving with 25 meter per second. 25. How did it come? It's a 10 plus 15 towards him. Yes, or even B can say the same. Even B can say the same, that A is moving towards him with a speed of 25 meter per second, provided he himself is being at rest. I hope these things are clear. So let's summarize this very quickly. Let's say this is object A moving in this direction. This is object B moving in this direction. So first thing, if I required velocity of A with respect to B. So when I have been asked velocity of A with respect to B, that means I am interested in VAB. As these two objects are moving in the same direction, I need to subtract this. This is velocity of A minus velocity of B. This is velocity of A with respect to B. I hope these things are clear. Is it? This is first situation. Now the second situation is that this is my first object moving in this direction, this is my second object moving in this direction. Its velocity is, let's say, velocity of A, its velocity of B. This is VA and VB. Yes. As now I am interested in velocity of A with respect to B, then what I can have is VAB. As these two are moving in opposite directions, I need to add the quantity. It would be an VA plus VB. So this is the simply thumb rule of this questions, that if two objects are moving in same direction, I can add their quantities. But when I add their quantities, I must remember that I can add only a similar quantities, or I can just subtract a similar quantities. So if two objects are moving in the same direction, I need to subtract their similar quantities. Similar quantities, I mean their velocity can be subtracted to find out the relative velocity. Their displacement can be subtracted. Their acceleration can be subtracted if they are moving in the same direction. And if two objects are moving in opposite directions, I can simply add their similar quantities. That means velocity can be added or acceleration can be added, something like this. I hope those things are clear to you. Is it? So can we move to the numericals? Yes, these are very easy to solve kind of numericals, because this is relative velocity in one dimensions. You need to learn this two basic concepts and always focus on these two concepts and do the numericals. So let's begin with first numerical of today's class. Let's say they have said that this is a train having a length of 500 meter. I know this is very bigger data, but okay, we can use it. And this is moving with 72 kilometer per hour. You are here, even you are moving in this direction with a speed of 18 kilometer per hour. Yes. Okay. Now what you required is find out time required to cross the train. Find out time required to cross the train. So first let's convert this into a meter per second. It's a 72 kilometer per hour. So it's a 72 multiplied by 5 by 18. It is 18 fours are 72 and 4 fives are 20. It's a 20 meter per second. This is 18 kilometer per hour. 18 multiplied by 5 by 18. So this is 5 meter per second. Yes. First, tell me that this two objects, a train and a person, moving in the same direction, opposite direction. Yes, they are moving in opposite directions. So what I can write is I can have the relation v relative should be is equals to distance traveled divided by time taken. Now their v relative would be equals to 20 from the train side and 5 from the person point of view. It's a 20 plus 5 should be is equals to 500 divided by t. I hope these things are clear. So it's a 20 plus 5, it's a 25 should be is equals to 500 divided by t. So this t would be equals to 500 divided by 25. And if I solve this t should be is equals to 20 seconds. I hope these things are clear to you. Is it? Is it clear to you? Yes? Yes. Let's move on to the next question and do this very carefully. Let's say this is shorter version of train and this is of 250 meter and this is moving with a speed of 108 kilometer per hour because it is small shorter and you know little inertia. Yes. So this is another train of 250 meter, but this is moving with a speed of 54 kilometer per hour. These two trains are seems on a same track but they are not. This two trains are seems on a same track but they are moving on different tracks. So if I have been asked that find out time required, let's say this is train A, this is train B, by train A to cross train B, find out time required by train A to cross train B. How can you do this? It's this is 108. So let me do this. 108 multiplied by 5 by 18 and 18 6 so this is 30 meter per second. I hope these things are clear to you. Yes, this is completely done in mind and not on a pen and paper. It's a 54 it's a 18 threes and 3 fives it's in 15 meter per second. Yes, now both are moving in same direction or in opposite direction. Yes, both are moving in same direction. If they are moving on same direction, then I should write it as an v relative should be is equals to distance traveled divided by time taken. As these two are moving in same direction, I need to subtract it. So this is 30 minus of 15 should be equals to now listen to this very carefully. They need to cross it, and when you need to cross it, you need to travel the distance of the that train also. So you need to travel for train A to travel 250 meter of himself and 250 meter of train B as well. It's a 250 plus 250. This is 500 divided by t. Yes, I hope these things are clear. When in the previous question you have been traveled through 500 meter only. Why? Because this is a person. This does not have any significant length. I'm talking about the length because to cross each one you need to travel a length, but this is a train. This is a train and this both the trains have a significant length, so that's why I need to consider it. So this is 30 minus 15. It's a 15 is equals to 500 divided by t. So t should be is equals to 500 divided by 15, and if it is 500 divided by 15, this should be 500 divided by 15. It's in 100 into 5, and this is 5 into 3, so this 5 would be a gone, and this could be a 33.33 seconds. this much amount of time would be required. Yes, I hope these things are clear to you. Is it? Yes, ready to move for the next question? Are you? Shall we do it? Let's do it. The next question is, ball A is thrown in vertically upward direction with speed 20 meter per second, while ball B is released from the wrist from certain height h. Find out their relative velocity at time t. You need to find this. Go through the data very carefully, but do it fast. Make it quick. First, make the diagram that what the situation is, that they have given that this is ball A and it has been thrown in upward direction with a speed of 20 meter per second. This is another ball. It's a ball B. This is A, this is B, and this has been released from the certain height h. This is, let's say, u is equals to 0, and this is height h. What I can say is, now what I need to find it out, that find out their relative velocities at time t. So as I know that object A is moving in upward direction, so if it is moving in upward direction, what I can have is VA is equals to u minus of gt. Now the VB, what I can write is, it's a u plus gt, but as they mention u is equals to 0, this is 0 plus gt, which means only a gt. Now what I need to find out, I need to find out the relative velocity of these two objects. As these two are moving in opposite direction, what should I do? Shall I add their velocity or shall I subtract it? What should I do? Yes, I need to add this. And if I need to add this, if I need to add this velocity of A with respect to B, that would be equals to VA plus VB. Now VA it is a U minus of GT, and VB it is a plus GT. So this should be U meter per second. This is U meter per second, and my U is the 20. So that should be is equals to 20 meter per second. I hope these things are clear. Did it? Yes? Yes? What was your answer? Is it same? Is it? Okay. Shall I add something to this question? Shall I? So let's begin with the one more question of the same data in the previous question. Find out relative acceleration of A with respect to B. You need to find out the acceleration. You need to find out the acceleration of A with respect to B. How can you do this? Yes. So first, let's have a diagram of this. This was the situation. This has been in upward direction. This is moving in the downward direction. Now first tell me that what is the acceleration of A? What is the acceleration of A? Acceleration of A will be a g, and this g is acting in this direction. Now what is the acceleration of B? Yes, it is again a g, and this are moving in this direction. Now please listen this very carefully. I am interested in relative acceleration. So by carefully observing this, tell me that the direction of acceleration in both the cases are same or different. Direction of acceleration in both the cases are same or different. Yes, it is same. If it is same, if direction of acceleration is same in both the cases, what should I do? Shall I add them or shall I subtract them? Yes, you need to subtract them. So acceleration of A with respect to B should be is equals to acceleration of A minus of acceleration of B. And if I subtract it, this is g minus g would give me an 0 meter per second square. I hope this is your answer. Or did you make a mistake by having a 2 into g? Do you? No? Great work. I hope these things are clear to you. I hope these things are clear. Is it? So can you do this kind of questions? Are you sure? Are you sure this kind of questions can be done? Does it? Yes? Great. So let's move to the next question very quickly. What they said is that this is the 150 meter, and they have thrown a certain ball from here 50 meter per second. This is, let's say, ball A, and they have released the ball B from here, u is equals to 0, and these are on a same line. These two objects are on a same line. They ask is that, as shown in the diagram, find out time and location at which this two objects will collide. You need to find out the time and location. One more data that they can given is g is equals to 10 meter per second square. So what can I do? What can I do? Let's assume that these two objects will meet at this location, and let suppose that this is the distance x, and if it is distance x, this is h minus x. Let me derive this with common variables, so that even question has been asked with different data, you can do it. So this is x, this is h minus x. What can I write for ball B? I can have this, that x of B should be is equals to ut plus half gt square, while while they have provided that this u equals to 0, so this x of B should be equals to half into g into t square. Let's assume this is a distance of 1, and I assume that xb is equals to x. So let's write it out here. This is x only. Now what should be the relation for the A? It is h minus x is equals to ut minus of half gt square. This is relation number 2. Yes. So if I add this to, what would be the relation? Let's look. This is x plus h minus x, so it would be an h is equals to plus half gt square minus half gt square. I am going to add this plus half gt square minus of half gt square. This is equals to u into t. So what I can have is h is equals to ut. Thus I can have h is equals to u into t. My h was the 150, u was the 50, and t would be, I can find it out as a 3 seconds. So t is equals to 3 seconds. So what I can have is that this is the situation. This is 150 meter, and I have assumed an h. I have assumed an h for the ball B. So this is ball B, this is ball A. They are going to meet somewhere here, and they are going to meet at 3 seconds. So what was the difference? What is the distance at which they are meeting? Let's calculate this from here and then from ground as well. So what I can have is that x is equals to half gt square. Yes, this is equals to 1 by 2 into g would be a 10 into t would be a 9. So this is 2 5s are 10, and this is 45 meter from the top. If they have been asked from the ground, if they have been asked from the ground, then I can write like as that it's a 150 minus of 45. This is equals to 105 meter. So from the top they meet at the 45 meter, and from the ground they meet at a 105 meter. I hope these things are clear. Does it? Yes. Does it? Yes. Great. So from the ground and from the top it is clear now. So what we need to find it out, we need to find out the time and location. So time is the 3 seconds, and location is the 105 meter from the ground and 45 meter from the top. This can be done. Now we can do the same thing. We can do the same thing with the help of relative velocity approach. But let's have a look at this. This is having an initial velocity u, and this is having an initial velocity of u is equals to 0. This are having an acceleration due to gravity g, in which x in downward direction. Even this is having an acceleration due to gravity, in which x in downward direction. This two are having a separation. This two are having a separation of 150 meter. So if I write, let's say this is ub, this is ua. V relative. If I write v relative, it's this is moving in this direction. It's an and ub, this is moving in this direction. It's in ua plus ub, but unfortunately ub is 0, so it is an u only. It is basically a velocity of a. Now let's find it out, the a relative. It is both having an acceleration of g, so this is equals to 0. So what I can have is that v relative should be is equals to distance traveled divided by time taken. Then v relative, it's a 50 should be is equals to 150 divided by time. So this time would be a 3 seconds. Yes, that is what we get. And once we get the 3 seconds, once we get this 3 seconds, what I can have is, let's say this is first, this is second, this is third. I know that when object travels from initially at rest, it travels 5 meter in first seconds, it travels 15 meter in next seconds, it travels, tell me, yes, it's a 25 meter in next seconds. How did I did it? Yes, it's an x, 3x, 5x. It's an x is to 3x is to 5x. So if I need to find out the total distance, this 25 plus 15, 40, 40 plus 5, it's a 45 meter from the top. And same way from the ground can be determined after doing this. I hope those things are clear. The previous approach, is not incorrect one, but it is time consuming approach. This is very good approach according to the relative velocity. So please try to do this, and always try to do the things using a relative velocity. This will make our task much easier. Yes, I hope these things are clear to you. Is it? Okay, so let's move on to the next numericals. But before you go through this, are you done with this? Are you? Okay, let's move on to the next question. What they have given. A bird holds a fruit in its beak and flies parallel to the ground. So it must be moving in this. It lets go of the fruit at some height h. Okay. Describe the trajectory of the fruit as it falls to the ground as seen by the bird and as seen by the person on the ground. So it is moving with constant velocity in horizontal direction. By somehow at a certain height it is going to drop off. It is going to drop off the fruit at some height, and you need to find out the trajectory. Yes. So if you look at this diagram very carefully, that if it has dropped this at certain height, it will look like this. It will look like this by a bird. But for a person, if it has been released from this, it is something like this. Yes, because it is moving in positive x direction as well. I hope these things are clear. Is it? So according to the bird, the trajectory of this fruit should be a straight line. But according to the person on the ground, it must be an parabola. Yes, I hope you understand what the parabola is. Yes. So this is would be the answer of this question. For the person, it should look like a parabola, and for the bird, it should be a straight line. We are going to discuss this concept again in the next unit. It's a motion in a straight line. Yes, but at this point of time, let's move to the next question quickly. Go through the data very carefully. You are going to do this by your on your own. What they have given is that bodies are dropped, that means u is equals to 0, from a height in successive intervals of half of a second. In a half of a second, what you need to find, you need to find out the relative velocity of one with respect to other. How can you do this? So what you can write is that I can have a one relation which gives me a v is equals to u plus gt. So for the first ball, this u equals to 0 and g into time is the half. So this velocity would be g by 2. Now at this time second ball is just being ready to be dropped. That means it is having an initial velocity of 0, and both are moving in the same direction, as this is the first ball and this should be the second ball. This two have a time interval of half of the second between this two. So what you need to find out, you need to find out the relative velocity of first with respect to the second. So as they are moving in same direction, it should be a subtracted, and as it should be a subtracted, it is g by 2 minus of 0 will give me a z by 2. I hope these things are clear. Is it? Is it done? Are you sure? Are you sure with this? Let's move to the next question very quickly. What the data is given, do it fast. What they have given is a bus starts from rest and move with uniform velocity of 1 meter per second square. So this is bus, and it is moving with a speed of 1 meter per, sorry, acceleration of 1 meter per second square, and it has started from rest. So this is u is equals to 0 for the bus. Now a boy 10 meter behind, so distance between boy and bus, it's a 10 meter. Bus at the start runs at a constant speed and catches the bus in 10 seconds. Okay, so you need to find out the speed of the boy. How can I do this? What I can conclude is that boy is having an motion with no acceleration. That means the acceleration of a boy is 0, while bus is moving with the accelerated motion. As they said that boy catches the bus in 10 seconds, that means boy and bus should be at the same location after 10 seconds. If it is so, then and then only a boy can catch the bus. So what I can write is that distance traveled by boy should be is equals to 10. This is the separation, plus 10 into t. How could I do this? It's a v is equals to x by t. So I can have that x is equals to v into t. This is velocity of, this is, so 10 into v, sorry, my mistake. Yes, it's a 10 into v. This is equals to time taken is 10 seconds and velocity that I need to find out. Yes, and what should be the distance traveled by bus? It's a half into a into t square, because they have given that it has started from the rest. Now acceleration, that is 1 meter per second square, and time is 10 seconds. So this is equals to half into 1 into t square. It's a 10 seconds, so this should be an 100. So this would be a 50 meter. I hope these things are clear. Now as I know that boy is going to catch the bus, so this two distance should be a same. This two distance should be a same, and if it should be a same, it's a 10 plus 10v should be is equals to 50. So this 10 into v should be is equals to 50 minus 10, 40. And if it is 40, that v should be is equals to 40 by 10. It's a 4 meter per second. I hope these things are clear. Is it? Is it? What was your answer? What was your answer? This is velocity of boy. This is velocity of boy. What was your answer? Is it same? Is it? Are you having the same answer? Does it? Great. So let's move on to the next question. Let's move on to the next question. Go through this data very carefully. What they ask is that a car starts with a constant acceleration of 2 meter per second square, and at the same instant a truck traveling with a constant speed of 10 meter per second overtakes and passes the car. Now they ask is ki how far beyond the starting point will the car overtake the truck? Yes. First, imagine the situation that what may happen, and have a rough sketch of it. Yes, what all they have given. What all they have given. Initial velocity of the car, which is u is equals to 0. And what again they have given is acceleration of car is 2 meter per second square, and speed of the truck, it is at 10 meter per second. So you need to find out the distance. So let assume that t is the time after which car overtakes the truck. So when car overtakes the truck, that means distance traveled by the car in time t, that must be equal to the distance traveled by the truck in time t. Then and only then situation arises that car can overtake the truck. Now what should be the distance traveled by car? What I can write is x distance traveled by car is equals to ut plus half at square. As I know u is given as a 0, so I can write like this. It's in half into a into t square. So this is half at square. And the distance traveled by the truck, as it is not having any acceleration. It is not having any acceleration, so I can write like this. It's a u into t. So if I solve this, it's a t would be a gone, and t is equals to 2u by a. This is 2 into 10 by 2. It's a 10 seconds. So after 10 seconds, after 10 seconds, car is going to overtake the truck. Now distance traveled beyond which they met, it's a u into t. U is the 10, time is the 10. So the car overtakes the truck after traveling for a distance of 100 meter. Yes. Do you understand this? Do you? Do you understand this? Yes? Let's move to the next question. This is one of the favorite question of examiners. So please do this very carefully. Go through the data carefully. What they have given. Go through it. What they say it is the driver of an express train traveling at a speed of v1 sees on the same track at distance d in front of him a goods train traveling in the same direction at a speed of v2. Immediately he applies brake to his express train, producing a retardation of a to avoid collision. Then you need to find out that what should be his acceleration so that he can avoid the collision. Yes, this is very interesting. So before I go to that, let's see that this is the situation. This is the v1, this should be the v2. They both are moving in the same direction and their separation is equal. Their separation is d. If I find out the initially relative velocity, then initial relative velocity, as they are moving in same direction, as these two are moving in the same direction, it should be an v1 minus v2. This is u relative, and their final relative velocity would be a 0. It's a v1 minus v2 and it would be a 0. Now I can have this relation v square minus of u square equals to 2as, and if I write this complete relation, if I write this complete relation in relative manner, this is something like this. It's a relative into s relative. I hope these things are clear. So if I write that, I know that their final velocity, their final relative velocity would be a 0, so that it's an v relative would be a 0. I need to find out the acceleration s into a into 2. So if I, let's find it out the a, then it should be an a is equals to minus of v1 minus v2 whole square divided by 2 into d. Yes, because d is the separation between these two. So this is the situation, this is the situation they when they will just collide. This is the situation when these two trains will just collide. So if you want to avoid the collision, if you want that collision could be avoided, your acceleration, technically it is a retardation because you are applying a brake and which will oppose the motion. So your retardation should be greater than this. If you can manage to do this, you can avoid the collision. If you cannot, and their acceleration, that means the retardation would be the same, then they will just collide. I hope these things are clear. Yes, please remember this very carefully, that when they are going to collide, when they are going to collide, they must be having same velocity. And if they are having the same velocity, their relative velocities would be a 0. Their relative velocities would be a 0. I hope these things are clear to you. Yes, let's look at some of the graphs with respect to the relative velocities. This is the first case where I have been plotted that position versus time graph for the two objects with equal velocities. This is position on the x-axis and this is time, or this is time on the x-axis, and this is position on the y-axis. Now the graph is of position versus time. If I find it out the slope, if I find out the slope, it will give me an velocity. So how can I find out the slope? With the angle theta. Yes, as both the having same theta. So both having the same velocity, but do these two objects will meet somewhere, or they are just moving parallel to each other and they are not going to move anywhere? Look at this. If I assume that this is the x is equals to 10 meter, if I assume this as a 10 meter, then object A has started with the 10 meter and object B has started with the 20 meter. So they are far apart by a 10 meter at very initial stage. That means t is equals to 0 seconds. and now they are moving with the initial velocities, and this initial velocities are equal, so they are not going to meet anywhere throughout that journey. I hope those things are clear. This is the graph where their relative velocity is zero, where their relative velocity is a zero, and they these two objects will never meet. Yes. Now let's go through the next quiz. Again, a position versus time graph is shown, and these two objects are moving with unequal velocities. These two objects are moving with unequal velocities. So let's look at this. This is the angle theta. Let's say this is theta 1, and this is a very small angle, it's a theta 2. As theta 1 is greater than theta 2, that means V1 is greater than V2. So as again the same case is there, that this object is started from the 20 meter, and this object has started from the 40 meter, but as both are moving with unequal velocities, that means that means that if this is moving in this direction, that at a certain position and at a certain time where they will meet, it is approximately this location where they intersecting. This is the location where they are met, and at time approximately 3 seconds. So at the intersecting position, these two are moving, but on a same way, these two are moving in the same direction. These two are moving on a same direction with unequal velocities. Yes. Would like to do one more case. Very interesting. Let's move on. This is position versus time graph of two objects with the velocity in opposite direction. Now they are moving in opposite direction, and what you required is time of meeting. Yes. So look at this. As you know, this is theta and it is positive. As you see, this is again theta, but it is a negative. Yes, so both are moving in opposite direction. First it's in V1, it's in positive, and second V2 is a negative. A point of intersection, a point of intersection is showing that these two objects are meeting at this position at this point of time. I hope these things are clear to you. Is it? So let's wind it up here. This is all about the relative velocity in one dimensional motion. Yes, please practice a lot. This will save us. Thank you. Have a good day. Take care. Bye bye.